All right, for this question, we're given the average hotel prices for the year, and let me move this. And then we have the population standard deviation, and we have a random sample of 42 hotels. So what's important to note here is the central limit theorem, okay? In most cases, if your sample size is 30 or larger, this will result in the sample means being a normal distribution, regardless of the shape of the population distribution. So we can assume that if it's 30 or more, that it is going to be normally distributed. And so when this happens, we can say the average of all possible sample means from all the samples is equal to the population mean. And the standard deviation is you're going to get the standard error of the mean by taking the standard deviation and dividing it by the square root of n. So since our problem is more than 30, we can assume that it's that the data is normally distributed. So first you're going to find the standard error of the mean. You take the standard deviation divided by the square root of n. The standard deviation is 25 divided by the square root of n, which is your sample, 42, and you get 386. So that's your standard error of the mean, and you're going to need that for all the other parts. So for part B, what is the probability that the sample mean will be less than 106? First, you have to find your z-score, and you're going to do your sample mean. That's what x bar means, is sample mean. So 106 minus your population mean of 103.36 divided by the standard error of your mean, which we just calculated, is 386. So when you calculate the z-score, you get 0.68. You use that z-score to get your probability, and the formula here is normal s dot dist. Your z value is 0.68, comma, cumulative true, because we want it to be all the way up to 106. We want it to be cumulative. If we want to know the probability that it's equal to 106, you would put false here, because you wouldn't want it to be cumulative. So your probability of less than 106 is 0.7517. And let me just show you. So when you check these, so it's showing 0.7531, but we'll also have an answer tolerance for that. So another answer you could get, which is what we got, was 0.7517. Now for the next one, you're going to do the same thing, but this time you're going to first have to find less than 110. Less than 110. And then you can do the 1 minus the less than to get the more than. Because it's always going to return the less than for this. So your z-score is 110. Your sample mean minus your population mean, which was 103.36, divided by your standard error of your mean, which is 386. So your z-score is 1.72. Do your formula here with your z-score and true. And this number is the less than side of 110. If we want the greater than side of 110, we will say 1 minus the less than side, the less than probability. Okay, so if you added the less than and the greater than probabilities together, remember the probability under the curve is always equal to 1. Okay, so there's your more than sign. Okay, let me just show you again. So I got 0.0427. So you can get either of these plus or minus 0.0001. So there's a lot of the answers that'll set here because of the rounding. Between 101 and 103. So you're going to do the same thing. You're going to do the z-score for 101. 101 minus 103.36 divided by 3.86. There's your z-score. Then do your formula. Normal s.dis negative 0.61 true. Now, it's a negative because we're doing a probability smaller than the population mean of 103.36. So it's going to be on the left side. So the z-scores on the left of the population mean are going to be negative. But you still will get an answer. You can have negative z-scores. Okay, so put that in and put true. Alright, and then do 103. Put that formula in. Do your normal.s.dis. Put your z-score and true. Now, to find in between, you take the probability of the larger one and subtract out the probability of the smaller one. So I did 0.4641 minus 0.2709, and you get 0.1932. And let me just show you that is an answer.